Alright guys, I hope you enjoyed homecoming weekend. So today we're going to dive into factoring polynomials. So last time we talked about polynomial operations, adding, subtracting, multiplying. But now we're going to kind of work the other way and do some factoring. So factoring is writing a polynomial as a product of its factors. If a polynomial cannot be factored, it is called prime. As an example, I'm going to do this one right here first. So this is two terms. This is a binomial. Now let's think about what do these two terms have, what do they have in common? So factor wise, I can factor out a 5 and I can factor out a single x because 15x to the y or xy and 5x squared, the only thing they have in common is 1x, not two of them. So my GCF is 5x. When you factor, the 5x goes on the outside and then what's left over goes inside parentheses. So now I have an x left over. 5 times -3 will give me -15. I've already got the 1x, but I need to add the y in there. And that is factoring out the GCF, which is always our first step when we factor anyways. So an example, this one right here. Think about 18 and 27. The biggest number, greatest common factor, least common multiple they have in common would be 9. And also think about how many x's can I pull out? Well, I can pull out x squared because that's the smallest exponent. That's what you're looking for. So if I have x cubed, x squared, and x, I would pull out an x. It just kind of depends on the problem. But this one has x cubed plus x squared, so I'm going to take out x squared. So I need to multiply this by 2x to get it back to 18x cubed. And 9x squared times +3 to get it 27x squared. So that's factoring the GCF. If you see something like this, the GCF is already factored. I'm just going to write these two together, x squared plus 5, and I'm going to multiply it by that x plus 3, what they have in common. That's it. So go ahead and pause the video. Might as well try C, just see if you can do it. If you paused it and tried it, hopefully you got 2xy squared as the GCF. Whenever I factor it, 2xy squared out, that's what I have left over, so it goes as parentheses, so that's called factoring. So independent practice, again, I encourage you to pause it, try these videos, or try these problems. So that's just some examples of the factoring the GCF. Now what we're going to do, we're going to talk about grouping. Guys, if you notice that it has 4 terms, we're almost always going to use grouping as our factoring method. So what you do, when we call it grouping for a reason, there's 4 terms. I normally group the first 2 together and the second 2. So what's the GCF of x cubed plus 4x squared? Well, that would be x squared, so then I have x plus 4 left over. What's the GCF of 3x plus 12? Well, that's a 3, and I have x plus 4 left over. When you do grouping, these should be the same, what's inside parentheses, and now I can combine it to x squared plus 3 times x plus 4. You combine what's on the outside into 1, and the x plus 4 is only written once. So again, same thing. Usually I group the first 2 and the last 2. And whenever you group, you should get the same thing in parentheses. So then you can rewrite it. Again, I strongly encourage you to pause the video and try these problems. So like independent practice right here, might as well pause it and practice 1 and 2. If I do grouping, factor out an x squared, the first group, I have x minus 2 left over. Factor out a -3, I have x minus 2 left over. So it becomes x squared minus 3, x minus 2. Same way here. Now this one's a little bit tricky because if you look at the first two, they don't have anything in common. But if you look at the first and the third, and the second and the fourth, they have something in common. So the first and the third, I can factor out a C. So I get 5A plus B left over. The second and the fourth, I can factor out a -2 and a D to get B plus 5A. Yes, these are written in a different order, but they're the same thing. So I get C minus 2D times 5A plus B. Okay? So that is factored by grouping. The last one is factoring trinomials. When you do this, all right, what you want to look at, if this is a 1 right here in front of the x squared, we're going to talk about the AC method in the next lesson, but if it's just a 1, all you have to do is look at the last term and list the factors of that last number and see what adds up to the middle number. So you list the factors of the constant term and see what adds up to middle number. So if I did the factors of 24, we got 1 and 24, 2 and 12, 3 and 8, 4 and 6. Which of those is going to add up to 11? Well, hopefully you said 3 and 8. And because they're both positives here, I'm going to break it into x plus 3, x plus 8. And whenever you FOIL, to work backwards, if you wanted to, you could FOIL to see, I should get what I started with, the x squared plus 11x plus 24. But this is what that factors into. B is a little bit harder because the factors are 12. However, if the middle sign is a negative and this is a positive, I'm multiplying two negative numbers together. Now, which of those is going to add up to -7? Hopefully you said -3 and -4, so this factors into x minus 3, x minus 4. The last one, if I do the factors of -19 to add up to a positive, right, I could do 1, -1 and a positive 19, or I could do 1 and -19. That's the only factors of 19. Notice none of those add up to the middle number, so it's not factorable. So we would call this prime. If you can't factor it, it's called prime. So I want you to practice 1 and 2. Again, I encourage you to pause the video. Yes, I'll go over it, but pause it and try them. So number 1, x squared plus 13x plus 40 factors into x plus 5 times x plus 8. Last one, if it's a negative, you want the bigger numbers to be negative. So 1, -14, 2, -7, 3, not 3. Those are the only factors of 14, -14. So this one right here adds up to a -5, which is what I want. So x plus 2, x minus 7. All right. And now, last thing we get into is special cases. All right. If you have something like this, notice there is no middle term. But if you square root both of these, they're both perfect squares. So what I would really focus on would be the last number. What's the square root of 4? Well, that's 2. So if you have no middle term, that just means you use a plus and a minus sign. Okay? Another one to think about, you can list the factors of 49, 149, 7 and 7. Okay? This adds up to 14. This is just regular factoring, x plus 7, x plus 7. But notice they're the exact same. So this turns into x plus 7 squared because there's 2 of them. So those are some special cases that you see. Here's the actual pattern that goes with it. So if it's a minus sign in the middle, if it's a plus sign, okay, and the difference of squares, you're going to see a lot. It's like this one, the square root of 81 is 9, so I do x minus 9, x plus 9. Next one, okay, I do the factors of 9, I get 1 and 9, 3 and 3. x plus 3 squared. 2 more, get a little bit harder on you. All right, notice there is no middle term, there's only 2 terms, but all of these are perfect squares, so if I square root them, right, I get 6x squared for the first term, minus 5y for the second one. And I'm going to write the same thing, but instead of using a minus, I'm going to use a plus because there's no middle term, so I want it to cancel, and that would be it. Last one, looks intimidating, but the first number and the last number are perfect squares. So if I do 5x minus 6 times 5x minus 6, because a negative 6 adds up to a positive 36 or multiplies to a positive 36. So these are just some special cases, and I know those last two are probably the most difficult ones. But that's just stuff you're going to see with basic factoring. So next time we're going to get into the AC method and talk about that, where it makes it a little bit harder. If you don't understand factoring, make sure you're reaching out for help. There is a paper assignment that goes with this one, and then the next time we're going to do a Hawks assignment. All right? Hope you guys have a good day. We'll see you later.